Hello students, today we will discuss class 11 organic chemistry. Okay, first we will study about the basic concepts, that is basic principles and techniques of organic chemistry. Then we will continue thereafter. Okay, now what are the topics that we will focus on this chapter? That is, first is basic concepts of organic chemistry. Okay, in basic concepts of organic chemistry, what are the things that we will focus? What are the points? First of all, what is the definition of organic chemistry? Then what is tetravalency? What is the tetravalency of carbon atom? Then what is catenation? Next point is what is the hybridization of carbon and its application? What is electronegativity? Then how will we represent the organic compound? Then what is the classification? Functional group, next homologous series, icse nomenclature, and then isomergy. Okay, this all comes under your basic concepts of organic chemistry. Okay, then next after this we will start our GOC, that is general organic chemistry topic. Okay, now let us start. First of all, what do you mean by organic chemistry? Organic chemistry is defined as the branch of chemistry which deals with the study of carbon compounds. Carbon compounds means hydrocarbons. Hydrocarbon consists of two elements, one is carbon and hydrogen. Only carbon and hydrogen is there in hydrocarbons and their derivatives. And here one thing important, they accept the carbides and oxides of carbon. Okay, except these compounds, the all other hydrocarbons and their derivatives comes under the organic chemistry. Okay, now first of all, who derived the organic term, the organic chemistry? How will you know the organic compound is derived? So first of all, our scientist Kohler, when he was doing one experiment in the laboratory, and when he heated the ammonium cyanide, which is purely an inorganic compound, when he heated that compound, then he got one compound, that is urea, which is purely an organic compound. Okay, the first organic compound which was invented in the laboratory is urea. Okay, and that was invented by your Kohler. Then now, what is tetracovalency or tetravalency of carbon atom? We know that carbon having atomic number 6. What is the ground state electron configuration? 1s2, 2s2, 2px1, 2py1, 2pz0. So 2 electrons in the 2s orbital and 1 in 2px, another in 2py. Okay, and no electron in the 2pz orbital. Then what is in the excited state? In the excited state, because these are degenerate orbitals. Degenerate orbitals means the orbitals having similar in their energies, nearly similar in their energies. So there is a chromosome, or there is a shifting of electron takes place from one orbital, 2s orbital to 2pz orbital takes place. So in the excited state, one electron from the 2s orbital is shifted to 2pz orbital. So in total there are 4 unpaired electrons are there, to which carbon can combine with another 4 elements that may be similar or differently similar, another 4 elements to form the bond. Okay, so that is why it forms its tetravalency. Okay, now next is what is catenation. What do you mean by catenation? Catenation is the self-linking property of an element to form chains of different sizes and rings is known as your catenation. Self-linking property of carbon, for example, if you will take carbon by linking with itself, it forms different types of chains, maybe a straight chain, maybe a branch chain, and maybe it form a ring compounds. So this property is known as your self-linking property of an element is known as your catenation. Okay, now what are the what are the factors on which catenation depends? Normally catenation depends upon the bond enthalpy. Catenation depends, bond enthalpy means bond energy. So catenation depends upon the bond enthalpy. Then what is about the order of catenation, and what is the stability of the catenation? Stability is directly proportional to bond enthalpy. And what is the order of catenation? If you will see, then almost carbon, which is maximum, then in silicon and sulfur it is nearly same, then phosphorus, then nitrogen, then oxygen. So this is the order of catenation. Okay, and greater is the bond enthalpy of an element, greater is the stability of that compound, of that element. Okay, so this is the direct relationship of bond enthalpy with stability. Okay, next we will discuss what is about the hybridization in the carbon. Hybridization, how many types of hybridizations are there, you know? How many types of hybridizations? If I'll write, one is your sp3 hybridization, one is your sp2 hybridization, and another one is sp hybridization. If one s orbital combines with 3p orbital, it is sp3 hybridization. One s combines with 2p, it is sp2, and one s combines with p, it is sp hybridization. Now what is the percentage of s character? Percentage of s character is here 25%. In sp2 it is 33.3%, and in sp it is your 50% s character. Okay. Then what is about the geometry of the molecule? If it is sp3 hybridization, the geometry of the molecule is tetrahedral. That you have to remember. If it is sp2 hybridization, then the geometry is trigonal planar. Trigonal planar. Similarly, if it is your sp hybridization, then the geometry is linear. Okay. Now what is about the bond angle? If the hybridization is sp3, then the bond angle is 109 degree to 8 minutes. If it is trigonal planar, then the bond angle is 120 degree. And if it is your linear structure sp hybridization, then the bond angle is 180 degree. Okay. Now next is, what is the type of bonds and what is the bond length? What are the number of sigma and pi bonds? If we'll take the sp3 hybridization, okay, if we'll consider sp3 hybridization, the structure is tetrahedral. That means all alkanes, the carbon-carbon single bonded compounds, carbon-carbon single bonded compounds, they comes under your sp3 hybridization. Similarly, in case of carbon, if in between two carbon atoms there is a carbon-carbon double bond is there, then it comes under your is your sp2 hybridization. Okay, it is your sp2 hybridization. Similarly, if it is sp hybridization, that means the carbon-carbon triple bond is there, then it is your types of bond, it is your sp3 hybridization. Now, if the in between carbon-carbon single bond is there, then the bond length is 1.54 angstrom. Okay, and if it is carbon-carbon double bond, then the bond angle is 1.34 angstrom. And if it is carbon-carbon triple bond, then the bond angle is 1.20 angstrom. Okay. Now what is the number of sigma bonds? If in between carbon and carbon one single bond is there, then that is always a sigma bond. Okay. That is always a sigma bond. That means the number of sigma bond in carbon-carbon single bond is 1. If in between carbon and carbon double bond is there, then 1 sigma and 1 pi. See here, if in between carbon-carbon single bond only one bond is there, that is sigma bond, then there is no pi bond, that is 0 pi bond. If in between carbon-carbon double bond is there, then 1 sigma, 1 pi. That means this is 1 sigma and this is 1 pi. Similarly, if triple bond is there, then here 1 is your sigma bond and 2 is your pi bond. Okay. So this is about the number of sigma and pi bonds present in between carbon and carbon. Okay. Single bond, double bond and triple bond. Now next we will discuss about 3 points. One is, what is the relationship between the percentage of S character with the size of the element. Greater is the percentage of S character, smaller is the size of the element. Okay. Now suppose if you will take an example, suppose if I will take example is if sp hybridization. In the sp hybridization, the percentage of S character is, if you will see, in sp hybridization the percentage of S character is maximum, that is 50%. So even the percent of S character is more, the size of the element is less. That means the compound in which the hybridization is sp, that is the structure is linear, the size of the corresponding element is less. So there is an inversely proportional relationship. Similarly, bond enthalpy is also inversely proportional to bond length. Bond enthalpy is also inversely proportional to bond length. That means the element having bond length, see here, the element having bond length, the compound in which carbon-carbon triple bond is there, the bond length is the lowest bond length, then the compound having highest bond enthalpy. In carbon-carbon triple bonded compound, the bond enthalpy is higher, right? Because there is an inversely relationship between this. Third one is percentage of S character is directly proportional to the electronegativity of the carbon. That means if we will say different type of hybridization, if we will take different types of hybridization, sp3, sp2 and sp hybridization, what is about the where the percentage of S character is more? In the sp hybridization, the percentage of S character is more, 50%. That means the electronegativity value of the compound having sp hybridization is more than sp2 than sp3. So what is the order of electronegativity? Here what is the order of electronegativity if I write? Then here the order is sp hybridization is greater than sp2 is greater than sp3. Okay. Similarly, what is the order of size of the size of the elements? Size of the elements, the order of the size of the element is here the sp3 hybridization. In case of sp3 hybridization, see here, already we have discussed size is inversely proportional to percentage of S character. Lowest the percentage of S character, greater is the size. What is the order of the size? The lowest is the percentage of S character, greater is the size. So sp3 is greater than sp2 is greater than sp. Similarly, what is the order of bond length? Bond length already we have discussed. The bond length is inversely proportional to bond enthalpy. So here what happens? Bond length is inversely proportional to bond enthalpy. So what is the order of bond length here? In case of this, the bond length of carbon-carbon triple bond is less than carbon-carbon double bond is less than carbon-carbon single bond. See here, what is the order of bond length? Always the maximum is in carbon-carbon single bond, then double bond, then triple bond. Okay. Similarly, this is the order, means this is the increasing order of bond length, this is the decreasing order of size. Okay. Similarly, what is the order of bond enthalpy? What is about the order of enthalpy? We already know that bond enthalpy is inversely proportional to bond length. That means the order of bond length is a reverse of that of the bond enthalpy. See, so here what is the order? This is greater than double bond, this is greater than single bond. Okay. Now, next we will discuss some examples where we have to calculate the number of sigma bonds and pi bonds, as well as we can identify how many sp2, how many sp3 and sp hybridizations are there, and what are the different types of hybridizations here. Suppose, see, this is an example of a compound where, first example, CH3. Okay. The hybridization of this compound is here. We know that in between carbon and carbon there is a single bond. This carbon is attached to single bond with all the sides. That means this is your sp3 hybridization. Okay. Now again this carbon is attached to one side one single bond, another side one double bond. Always remember one thing. एक बात ये याद रखो, एक कार्बन अगर और अदर कार्बन के साथ एक भी साइड में आपका डबल बॉन्ड आ जाता है, देन दैट कार्बन बिकम्स योर sp2. मे बी आपका एक साइड में सिंगल बॉन्ड रहे, बट अगर एक साइड में आपका डबल बॉन्ड आ जाता है, देन आप उस कार्बन को sp2 हाइब्रिडाइजेशन कंसिडर करोगे, बिकॉज दिस इज योर sp2 हाइब्रिडाइजेशन. Then again this carbon, see here the single bond is there, but again other side there is a double bond, so this carbon CH is your sp2. Okay. Similarly, because already we have discussed, if the hybridization is sp3 carbon-carbon single bond, sp2 carbon-carbon double bond, sp carbon-carbon triple bond. Okay. So now this, see here, this carbon is attached to two single bonds this side, so this is again sp3, and this carbon is attached to one single bond, another one triple bond. Triple bond is this carbon is your sp, and this carbon is also attached to a triple bond, so it is also sp hybridization. So all total, if you will see, there are two sp hybridization, two sp2 hybridization, and two sp3 hybridizations are there. Okay. Next we will calculate in this compound how many sp, sp2 and sp3 hybridizations are there. See, this carbon attached to only single bonds, so again this is your sp3. This is again one double bond is there, so it means it is your sp2. Again this one is also sp2. This carbon is attached to triple bond with nitrogen, that means this is your sp hybridization. Okay. Now see here, this carbon is attached to a double bond with other carbon atom, so it is your sp2. Now see here, one important point always remember, if a carbon is attached to a double bond to other carbon atom in one side, then that carbons are treated as your sp2 hybridized carbon atom. But if a carbon is attached to other two carbon atoms by two double bonds, on both the sides, then the structure of the compound shows a linear structure, and the hybridization of the carbon is known as sp hybridization. It is not sp2, it is sp hybridization. Structure becomes a linear. Okay. Similar, now next is this carbon. This is attached to a double bond along with single bond, so it is your again sp2, and this carbon is only single bond, so it is your sp3. Okay, समझ में आया? How can you show the what type of hybridizations are possible if in a compound single, double and triple bonds are there? Okay.